Hello everyone, this is Abebe Chukala from IHE Delft. This lecture video demonstrates how the protocol can be used to assess WaPOR-based land and water productivity. The seasonal actual water consumption and seasonal net primary production, which are calculated from WaPOR datasets, can be used to calculate WaPOR-based indicators such as land productivity and water productivity. Land productivity is defined as the above ground biomass production or crop yield in ton per hectare per season, which are estimated from the seasonal net primary production. The seasonal net primary production first corrected for moisture content in the fresh biomass and then multiplied by light use efficiency correction factor, which is crop specific, and then multiplied by above ground over total biomass production ratio. This leads us to above ground biomass, and then crop yield can be calculated by multiplying the above ground biomass by harvest index. The biomass water productivity is then calculated by dividing the above ground biomass over the seasonal actual evapotranspiration, and then the crop water productivity is calculated by dividing the crop yield to the seasonal actual evapotranspiration. There are four main steps to run this module. Firstly, make sure the input data to the module are ready. That is, the preceding module is complete. Secondly, launch the Jupyter notebook. The simplest option to open the Jupyter notebook is start with opening the WaPOR WP master folder, which is downloaded from the GitHub repository. In the open folder, in its address bar, type Jupyter notebook and press enter key. That leads you to open Jupyter notebook environment. Then thirdly, open notebooks folder, and it shows all the modules in the protocol. Finally, run the module. From the launched Jupyter notebook, we click on notebooks, and then to run module 4, we click on module 4 here. Module 4, which helps to calculate land and water productivity, has three main steps. It starts with setup and then calculate land productivity, which is biomass and crop yield, and finally it calculates productivity, which is biomass water productivity and crop water productivity. So the setup, it starts importing the standard package and library, which are inbuilt in Python package. And so to import that, we select the cell and then click on Run button. The second step is to calculate land productivity, that's biomass and crop yield. So the biomass is calculated from net primary production corrected for moisture content of the fresh biomass and then multiplied by the light use efficiency correction factor, which is specific to the crop, in this case sugarcane, and then finally multiplied by the above ground to the total biomass ratio. So those values, in fact, those crop parameters has to be referred from literatures or maybe from the experiment they are known. So in this case, we are referring the default crop parameters used in WaPOR portal, which can be accessed from the WaPOR webpage. So to do the analysis first, we import the net primary production raster data, which is seasonal and calculated at module 2. So we click on the cell and then we select this cell and then click on run button to import the data. And then for sugarcane, we have a crop parameters. So here we select those parameters specific to the sugarcane because we are calculating for Sinabana, which is sugarcane crop. But if you are running this module for different crops, different project or study area, and then different crops, so the crop parameter has to be adjusted here. So the crop parameters we are referring are moisture content, the light use efficiency correction factor specific to the crop, and the above ground over the total biomass production. So we select on the cell and then click on run. So those parameters for sugarcane are imported. Then we create the output folder to save the calculated biomass. So here we have a name for that, which is for L2 biomass, which will be created under the data folder. So if we select the cell and then click on run, so the folder has to be now created. So here is state to calculate the above ground biomass and to save it in the folder as well as also to plot it. So if we select the cell and then click on the run, then the calculation will be made. So crop yield is then calculated by multiplying biomass by the harvest index. So to do so, first again we have to import the biomass or above ground biomass layer, which we just calculated now. So we import that and then we assign harvest index. In this case for sugarcane is 1, just we referred it from the default parameter on WaPOR page. But those values for different crops, even it can be for sugarcane, also has to be adjusted based on knowledge and literature. So we import this harvest index and then we create the output folder where the calculated yield to be saved. And then we calculate the crop yield. So we select the cell which has a script to calculate the crop yield and save it in the folder, also to plot it. And then we click on run. So this is calculated. The third step is to calculate water productivity. So it has two components, biomass water productivity and the crop water productivity. So to calculate the biomass water productivity, which is the ratio of biomass over seasonal actual evapotranspiration, first we import the relevant input, which are seasonal actual evapotranspiration calculated at module 2 and the biomass, above ground biomass, which we just calculated in this module. So we select this cell and then click on run button. So those input layers are imported. Then we create the output folder. In this case, we gave a name for L2 WPB for biomass water productivity. So we create that folder under folder data and then we calculate the biomass water productivity by selecting on the cell and then clicking on the run button. So the final step is to calculate crop water productivity, which is the ratio of crop yield over seasonal actual evapotranspiration. That starts with importing seasonal actual evapotranspiration and crop yield. The crop yield is just calculated in this module. So we import that, and then we create output folder with the calculated crop water productivity to be saved, in this case for L2WPY. This is just the name we gave here, and you could even rename if you want. So we select and click on the run button, and finally we calculate the crop water productivity. So this is then the final part of module 4. So we can check whether the calculated layers are in the data or not. So if we go to the data, and then we could see for biomass calculated, biomass water productivity calculated, crop yield is calculated, as well as crop water productivity is calculated. So this is the end of module 4. Thank you very much for listening to this lecture video.